Okay, the second part is using those definitions of same side interior, same side exterior, exterior angle theorem, exterior interior angle theorem, and the corresponding angles postulate. So we have our first proof right here. So whenever we write proofs, we're going to have two lines like this. And over here on the left-hand side, you write conclusion. And on the right-hand side, you write justification. Okay, other first thing we do is we write down our given. So we know that A is parallel to B, and our justification is given. So we also need to mark it on our diagram that these two lines are parallel. I'm trying to prove that angle 1 and angle 4 add up to 180. So they're not same side interior and they're not same side exterior. But from the lesson, if we have two parallel lines cut by a transversal, we have a lot of angle pairs that are congruent. So the first that I'm going to do, I'm going to work with 1 and 4 because that's where I want to end up with. So I'm going to pick angle 1 and say that angle 1 is congruent to 3. So why is angle 1 congruent to angle 3? They're corresponding angles. So angle 1 is congruent to angle 3. So I write the corresponding angle postulate. Now I can write that. I can mark it on my diagram that these two are equal. So what's special about 3 and 4? They add up to 180. So I'm going to write the measure of angle 1. I don't want to write angle 1 plus angle, or measure of angle 3 plus the measure of angle 4 equals 180 degrees by supplementary angles. You could also put these are actually called linear pairs. If they make a line, linear pairs. So the definition of a linear pair is that they're supplementary and form a line. So they add up to 180 and they make a line. They're a linear pair. So you could also put the linear pair theorem right there. So my line at the bottom is angle 1 and angle 4 are supplementary. So I want to have at the bottom measure of angle 1 plus the measure of angle 4 equals 180. So I'm going to write that in already. Measure of angle 1 plus the measure of angle 4 equals 180 degrees. So let's look what we have already. We have angle 1 is congruent to angle 3, and 3 plus 4 is 180, but we want to get 1 plus 4 is 180. So what I'm seeing here is this part and this part are the only differences between these two lines. But we already know right here that angle 1 is congruent to angle 3. So actually, if angle 1 is congruent to angle 3, then I can say by substitution, instead of writing angle 3 right here, I wrote angle 1. So my final line is substitution. So there's my proof. Number 2 is kind of open-ended. Write conclusions and justifications from the diagram below. Conclusions, justifications. So I see right here that these two lines are parallel. So we can make a ton of conclusions here. So first, what's up with 1 and 5? What kind of angles are they? They are corresponding angles. So angle 1 is congruent to angle 5 by the corresponding angle postulate. Also by the corresponding angle postulate, 3 and 6 are congruent. And then I could say that I could do 4 different pairs of corresponding angle postulates. I want to do some alternate interior angles. So angle 2 is congruent to angle 6. Oops, I don't have the angle symbol. By alternate interior angles. And I'll do an alternate exterior. So 3 and 7. Angle 3 is congruent to angle 7 by alternate exterior angles. You could do some same side interior angles. You could say that the measure of angle 2 plus the measure of angle 5 equals 180 degrees. They're same side interior angles. There's a lot of different justifications that you can make. Okay, second part, let's fill in some angles. So, if we're given that these two lines are parallel, this is my transversal. So I can fill in all these other angles. I know that this one has to be 42 degrees because they're vertical angles. I know that this has to be 138 degrees because 42 and 138 form a linear pair. I know that this has to be 138 degrees because they're a linear pair and vertical. And now I can use corresponding angles or alternate interior angles to copy down here. This has to be 42 because it's corresponding. This has to be 138. So this are 138 and this is 42. So you should be able to fill in all those different angles. Number 4, we're given two parallel lines because of this. Now I'm going to make it easier to see, and I'm going to make this one, I'll call this one the red transversal. This one's the green transversal. So I'm going to fill in, I know that this has to be a linear pair, so this is 115. This has to be a linear pair, so this is 140. But just look at my red line right here. I'm trying to figure out what A is. A is an alternate exterior angle of 65, so A is 65 degrees. C is an alternate interior angle of 40, so this is 40 degrees. So now I just had to figure out B. So there's two ways you can do it. You can do it that maybe you know that a triangle adds up to 180, so you could do it that way. Or you could do that this adds up to 180. So I do 180 minus 40 is 140 minus 65 is 85 degrees. So B is 85 degrees.